Hello students, welcome to this lecture one quadratic equation. So in this lecture, we will discuss exercise 4.3 of NCERT. Okay, so let's get started. So in question number 1, here we have to find the nature of the roots of the following quadratic equations if the real roots exist. Okay, then we have to find that. So first of all, you have to find the nature of the roots of this following quadratic equation, and then if real root exists, then find them. Okay, so here in first equation we have 2x squared minus 3x plus 5, this is equal to 0. Okay, so let us solve this equation. So we know that for a quadratic equation, ax squared plus bx plus c is equal to 0. Discriminant is b squared minus 4ac, and we know if b squared minus 4ac this is greater than 0, then it implies two distinct real roots. If b squared minus 4ac this is 0, then it implies equal real roots. And if b squared minus 4ac this is less than 0, then no real roots. Okay, that means when for a quadratic equation has two distinct real roots if the discriminant is positive. And for a quadratic equation, this quadratic equation has two equal roots if the discriminant b squared minus 4ac is equal to 0. Okay, and for this quadratic equation, this equation has no real roots if b squared minus 4ac this is less than 0. Okay, so here basically the sign of b squared minus 4ac, it determines the quadratic equation has real roots or not. Okay, so now in the first equation we have this equation 2x squared minus 3x plus 5 is equal to 0. Okay, so now comparing this equation with the standard form of the quadratic equation ax squared plus bx plus c is equal to 0, we obtain the value of a is 2, value of b is minus 3, and the value of c is equal to 5. And here the discriminant is equal to b squared minus 4ac, and this is equal to minus 3 squared minus 4 times 5. And this is equal to 9 minus 40, and this is equal to minus 31. So here as b squared minus 4ac, this is less than 0. So therefore, no real root is possible for the given equation. Okay, so therefore, no real root is possible for the given equation. Now, let us see next equation. So in next equation, we have 3x squared minus 4 times 3x plus 4 is equal to 0. Okay, so here we have to first compare this equation with the standard form of the quadratic equation ax squared plus bx plus c equal to 0, and then we'll get the values of a, b, c, and then we have to find the value of b squared minus 4ac. Then if b squared minus 4ac is greater than 0, then this quadratic equation will have distinct to real roots. If b squared minus 4ac is equal to 0, then this quadratic equation will have two equal roots. Okay, and if discriminant is negative, then this quadratic equation will have no real roots. Okay, so let us see what types of roots will be exist for this quadratic equation. So we have given this quadratic equation 3x squared minus 4 times root 3x plus 4 is equal to 0. So comparing this equation with ax squared plus bx plus c is equal to 0, and we obtain a is equal to 3, b is equal to minus 4 times root 3, and c is equal to 4. And the discriminant is equal to b squared minus 4ac. This is equal to minus 4 times root 3 whole square minus 4 times 3 times 4. And here this is equal to 48 minus 40, this is equal to 0. Okay, so the discriminant is equal to 0. So as b squared minus 4ac, this is equal to 0. Therefore, real roots exist for the given equation, and they are equal to each other. And the roots will be minus b upon 2a and minus b upon 2a. So here minus b upon 2a, this is equal to minus 4 times root 3 divided by 2 times 3. and this is equal to 4 times root 3 divided by 6, and this is equal to 2 times root 3 divided by 3, and this is equal to 2 by root 3. Okay, so the value of minus b upon 2, this is equal to 2 upon root 3. So therefore the roots are 2 upon root 3 and 2 upon root 3. Okay, so the equal roots of this quadratic equation are 2 by root 3 and 2 by root 3. Now let us see third equation. 2x square minus 6x plus 3 is equal to 0. Okay, so this is a quadratic equation. So here we have to check the nature of the roots of this quadratic equation, and if the real roots exist for this quadratic equation, then we have to find them. Okay, so let us solve third equation. So we have given 2x square minus 6x plus 3 is equal to 0. So now comparing this equation with ax square plus bx plus c is equal to 0. Okay, so here we obtain the value of a is 2, b is minus 6, and c is equal to 3. And here the discriminant is equal to b square minus 4ac, and this is equal to minus 6 whole square minus 4 times 2 times 3, and this is equal to 36 minus 24, and this is equal to 12. Okay, so as b square minus 4ac, this is greater than 0, so therefore distinct real roots exist for this equation. Okay, so as follows, we can find the two distinct roots by using quadratic formula. Okay, so we know the quadratic formula x is equal to minus b plus minus root over b square minus 4ac divided by 2a. And here the value of a is equal to 2, b is equal to minus 6, and c is equal to 3. Okay, so if we now put all these values, then we'll get this is x is equal to minus of minus 6 plus minus root over minus 6 whole square minus 4 times 2 times 3 divided by 2 times 2. And this is equal to 6 plus minus root over 12 by 4, and this is equal to 6 plus minus 2 times root 3 by 4, and this is equal to 3 plus minus root over 3 by 2. So therefore the roots are 3 plus root 3 by 2 and 3 minus root 3 by 2. Okay, now let us move to question number 2. So in question number 2, we have to find the values of k for each of the following quadratic equations so that they have two equal roots. Okay, so in first equation we have 2x square plus kx plus 3 is equal to 0. Okay, and in second equation we have kx times x minus 2 plus 6 is equal to 0. Okay, so now we know for a quadratic equations as two equal roots if the discriminant is equal to 0. Okay, so first for this one, we know that if an equation ax square plus bx plus c is equal to 0 has two equal roots, its discriminant b square minus 4ac will be 0. Okay, so now for this quadratic equations, here if we comparing this equation with ax square plus bx plus c is equal to 0, then we obtain the value of a is equal to 2, and the value of b is equal to k, and the value of c is equal to 3. Okay, now the discriminant is equal to b square minus 4ac, and this is equal to k square minus 4 times 2 times 3, and this is equal to k square minus 24. And now the discriminant will be 0. So here the k square for equal roots, the discriminant is equal to 0. So k square minus 24, this is equal to 0, and it implies k square, this is equal to 24, and it implies k is equal to plus minus 24, square root of 24, that is equal to plus minus 2 times root 6. Okay, so k is equal to plus minus 2 times root 6. Now for second one, so in second question we have kx times x minus 2 plus 6 is equal to 0. Okay, so let us see how to solve. So here we can first simplify this equation. Kx times x minus 2 plus 6 is equal to 0, that it implies kx square minus 2kx plus 6 is equal to 0. Okay, so this is our equation or equation. Now comparing this equation with ax square plus bx plus c is equal to 0, then we obtain the value of a is equal to k, the value of b is equal to minus 2k, and the value of c is equal to 6. Now the discriminant is equal to b square minus 4ac. Okay, and now if we put all the values a, b, c, then we get this is equal to minus 2k whole square minus 4 times k times 6, and this is equal to 4k square minus 24k. Now for equal rows, b square minus 4ac, this is equal to 0. So therefore 4k square minus 24k, this is equal to 0. Okay, and it implies 4k times k minus 6 is equal to 0. Okay, so either 4k is 0 or k is equal to 6. So we get the value of k are 0 and 0 or k is equal to 6. However, if k is equal to 0, then the equation will not have the terms x square and x. Okay, so when we take the value of x is equal to value of k is equal to 0, then the equation will have no terms x square and x. Okay, so for k equal to 0, the equation will not a quadratic equation. Okay, so therefore if this equation has two equal roots, then k should be 6 only. Okay, so k should be 6 only for getting two equal roots for this given quadratic equation. Okay, now let us move to question number 3. So here we have asked, is it possible to design a rectangular mango grove whose length is twice its breadth and the area is 800 meters square? Okay, so if so, find its length and breadth. So here we have basically asked, is it possible to design a rectangular mango grove whose length is twice its breadth? Okay, and here area is given 800 meters square. So now here let the breadth of the mango grove be L, and length of the mango grove will be 2 times L, since the length of this mango grove is twice the length, twice of the breadth of this rectangular mango grove. Okay, so area of the mango grove, this is equal to 2L times L, this is equal to 2L square, and given the area of this mango grove is 800 meters square, so we get this equation 2L square, this is equal to 800, and it implies L square, this is equal to 800 by 2, and this is equal to 400, and it implies L square minus 400, this is equal to 0. Okay, so now comparing this equation with AL square plus BL plus C is equal to 0, then we obtain the value of A is 1, B is 0, and C is 400. So now the discriminant B square minus 4AC, this is equal to 0 square minus 4 times 1 times minus 400, and this is equal to 1600. Okay, so here B square minus 4AC, this is greater than 0. So therefore the equation will have real roots, and hence the desired rectangular mango grove can be designed. Okay, so the desired rectangular mango grove can be designed. So the value of L is equal to plus minus 20. The value of L is equal to plus minus 20. Okay, however length cannot be negative, so here we neglected L is equal to minus 20. So therefore breadth of the mango grove, this is equal to 20 meter, and length of the mango grove is equal to 2 times 20, that is equal to 40 meter. Okay, so the length of the mango grove is equal to 40 meter, and the breadth of the mango grove is equal to 20 meter. Okay, so now let us move to question number 4. So in this question, here we have asked first, is the following situation possible? Okay, so if so, determine their present ages. So here sum of the ages of two friends is 20 years. 4 years ago, the product of their ages in years was 48. Okay, so here we have given sum of the ages of two friends is 20 years, and 4 years ago, the product of their ages in years was 48. Okay, so now here we let the age of the one friend be x years, and age of the other friend will be 20 minus x years. So 4 years ago, age of first friend is equal to x minus 4 years, and age of second friend is equal to 20 minus x minus 4. and this is equal to 16 minus x years. Okay, so now according to given information, x minus 4 times 16 minus x, this is equal to 48. And if we simplify, then you will get 16x minus 64 minus x square plus 4x, this is equal to 48. Okay, and it implies minus x square plus 20x minus 112, this is equal to 0. And it implies x square minus 20x plus 112 is equal to 0. So this is the quadratic equations of the following situation. Okay, so now comparing this equation with ax square plus bx plus c is equal to 0, then we obtain the value of a is equal to 1, b is equal to minus 20, and c is equal to 112. Okay, so now the discriminant b square minus 4ac, this is equal to minus 20 square minus 4 times 1 times 112, and this is equal to 400 minus 448, and this is equal to minus 48, and here b square minus 4ac, this is less than 0. So as b square minus 4ac, this is less than 0, so therefore no real root is possible for this equation, and hence this situation is not possible. Okay, so this situation is not possible. Now let us move to question number 5. So in question number 5, here we have asked, is it possible to design a rectangular park of perimeter 80 meter and area 400 meter square? So if it is possible, then find its length and breadth. Okay, so let us solve. Then let the length and the breadth of this park be L and B, and here perimeter, that is equal to 2 times L plus B, this is equal to 80. So it implies L plus B, this is equal to 40. Okay, so it implies L plus B, this is equal to 40, and it implies B is equal to 40 minus L. And we know area, that is equal to length into breadth. So area, this is equal to L into B, this is equal to L times 40 minus L, this is equal to 40 L minus L square. Okay, and here for this question, here we have given the area is 400 meter square. So 40 L minus L square, this is equal to 400. Okay, and it implies L square minus 40 L plus 400, this is equal to 0. And comparing this equation with AL square plus BL plus C is equal to 0, we obtain the value of A is equal to 1, the value of B is equal to minus 40, and the value of C is equal to 400. Okay, so now the discriminant B square minus 4AC, this is equal to minus 40 square minus 4 times 1 times 400, and this is equal to 1600 minus 1600, is equal to 0. Okay, so B square minus 4AC, this is equal to 0. So as B square minus 4AC, this is equal to 0, so therefore this equation has equal real roots, and hence this situation is possible. And now roots of this equation, that is A is equal to minus B upon 2A, and here the value of B is equal to minus 40, and the value of A is equal to 1. Okay, so the length L is equal to minus 40 divided by 2 times 1, this is equal to 40 by 2, and this is equal to 20. So the length of this length is equal to 20, and L is equal to, so here L is equal to 20. Okay, so therefore length of part L is equal to 20 meter, and breadth of part B is equal to 40 minus L, that is 40 minus 20, this is equal to 20 meter also. Okay, so here in this question, basically we have asked, is it possible to design a rectangular park of the perimeter 80 meter and area 400 meter square? Okay, so my answer is, it is possible to design a rectangular park of the perimeter 80 meter and 400 meters square. Okay, and here we have found the value of the length and breadth. Okay, so after solving, if we represent this situation in the form of quadratic equation, okay, then if we use quadratic formula for solving that quadratic equation, then we'll get the value of L. Okay, then we get the value of L. So here we get the value of L is equal to 20 meter. Okay, so the length of it is equal to 20 meter, and we know the breadth breadth is equal to basically 40 minus L is equal to 40 minus 20, that is equal to 20 meter. Okay, so it is possible to design a rectangular part of perimeter 80 meter and 400 meter square, and therefore its length is equal to 20 meter and breadth is equal to 20 meter. Okay, so in this lecture basically we have discussed exercise 4.3 NCERT class 10 books. Okay, so here we have discussed these questions, basically that best one, the solution of a quadratic equation by using quadratic formula. Okay, so I stop here this lecture. Thank you very much to all of you.